Good morning, all of you. In the previous class, we saw the characteristics of acids and bases. Acids have H plus ion in common. Bases have OH minus ion in common. So, when an acid is mixed with a base, H plus ions of acid will be combining with OH minus ions of base to form water. Acid plus base gives salt and water. You will be getting a salty water. This process is called neutralization reaction. Acid plus base gives salt and water. It's actually the formation of water. H plus OH minus gives H2O. This reaction is called neutralization reaction. Now the salt solution what is formed is neither acidic nor basic. If equimolar solution, if the concentration of this acid and base are equal, then the resulting solution obtained is neutral. Now next topic we are going to see how to dilute an acid or how to dilute a base. Dilution means addition of water, but water should not be added to acid. Instead, acid is to be added to water. Why? Because this dilution of an acid or base is an exothermic reaction, means lot of heat will be generated. If you are adding acid to water, heat is generated. That heat you keep on stirring while adding, during the addition you keep on stirring, so that heat generated will be mixing with that water. But if you are adding water to acid, the heat generated, see lots and lots of acid is there, that heat generated will cause local heating, and that solution may burst, and it will, the solution, the acid will be splashing maybe onto your face, and your body or the face gets burned. So never add water to acid. Instead, add acid to water. The heat generated may splash that liquid, splash that acid towards your face, on your face. So it is dangerous to dilute an acid by adding water to acid. Instead, you have to do what? You have to add acid to water. There also heat is generated. There also you will see some splashing effect, but that is a dilute one, not that whole acid and little bit of water. Okay, by mixing acid with water, you get a dilute acid. We say this process dilution, and the resulting solution is called dilute acid. In a dilute acid, the number of H plus ions in a particular volume, means in unit volume, the number of ions, H plus ions in that unit volume is less. We say it is a dilute acid, or the strength of the acid is less. Now, why? Because the number of ions present in a unit volume is less. So, the strength, that is the number, strength means the number of H plus ions in a particular volume, in a unit volume, that is less. So, the strength of acid has become less. Similar is the case with base. The number of OH minus ions in unit volume is less now after dilution. So, the strength of that basic solution, that is less. Let's see some questions. Why do HCl, HNO3, etc. show acidic characters in aqueous solutions, while solutions of compounds like alcohol and glucose do not show acidic character? In the last class we have seen HCl, HNO3, etc. dissociates into ions, H plus Cl minus ions, H plus NO3 minus ions. Ions are the carriers of electricity. Ions are the current carriers. But in the case of alcohol and glucose, if you put alcohol in water, this does not dissociate into ions, IONS. Similar is the case with the glucose. It will not provide any ion for the circuit to be completed or for the carriers of current. Next question, why does an aqueous solution of an acid conduct electricity? Aqueous solution of acid provide ions, H plus and OH minus ions. So these are the carriers of current. So it conducts electricity. It is a conductor. Why does dry HCl gas not change the color of the dry litmus paper? Acid shows its property, or acids can liberate H plus ions only in the presence of water. Only in the presence of water. So, in presence of water or moisture, or we can say in aqueous solution only, HCl can show its property. So, dry HCl means no H plus is liberated. Dry litmus paper means dry litmus paper cannot provide any moisture to this to dissociate. Even in presence of moisture also, this HCl dissociates to form H plus and Cl minus. So H plus is obtained only in the presence of water, moisture. So dry HCl means no water. Dry litmus paper means no water. So HCl will not show its property. While diluting an acid, why is it recommended that the acid should be added to water and not water to acid? So acid must always be added slowly to water with a constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. So, while diluting an acid, it is recommended that the acid should be added to water, not water to acid. Acid, when acid is added to water, then also this bubbling and splashing you will see. But since it is a dilute one, it will not cause burns. How is the concentration of hydronium ions, that is S3O plus, affected when a solution of an acid is diluted? When it is diluted, what will happen? The number of H plus ions or hydronium ions, we know that H plus ions cannot stay alone. It will be combining with water to form hydronium ion, H3O plus. So, the number of hydronium ions or number of H plus ions per unit volume decreases. How is the concentration? Means concentration decreases, affected when a solution of an acid is diluted. Means the concentration decreases. Concentration means the number of ions, number of H plus ions or number of hydronium ions in unit volume, per unit volume. That is decreasing, the concentration is decreasing. How is the concentration of hydroxide ion affected? When excess base is dissolved in a solution of sodium hydroxide, when excess base is dissolved in a solution of sodium hydroxide, You have a solution of sodium hydroxide. If you add a little more base, how is the concentration of hydroxide ion affected? The concentration of hydroxide ion will be increased because you are adding excess of base in that solution of sodium hydroxide. So per unit volume, per unit volume, the number of OH minus ions will be increasing. Next heading is how strong are acid or base solution. How strong are acid or base solution? We know how acid base indicators can be used to distinguish between an acid and a base. We have also learned in the previous section about the dilution and decrease in concentration of H plus or OH minus ions in solution. Can we quantitatively find the amount of these ions present in a solution? Can we judge how strong a given acid or base is? Can you find out the number of H plus ions or the number of OH minus ions? Can we quantitatively find the amount of these substances, these ions present in a solution? Yes, we can find out the number of H plus ions and number of OH minus ions. We can do this by making use of a universal indicator, which is a mixture of several indicators. The universal indicator, you know that litmus paper is an indicator. Similarly, another indicator, a paper only, a universal indicator shows different colors at a different concentration of hydrogen ions in the solution. Suppose more number of H plus ions or hydronium ions, it will show one color. Less number of H plus ions, that paper will show another color. If it is basic, another color. Less basic, some color. More basic, another color. So you dip this universal indicator paper, we call it as pH paper. You dip this pH paper in the given solution, check the color, and you will be getting one color. That color you match with the palette given. You match with the standard colors given, and you can say whether the substance is highly acidic, less acidic, or more acidic, or less acidic, high acidic, less basic, more basic. That depends upon the number of H plus ions. If the number of H plus ions is very high, it is a strong acid or it is strongly acidic. If number of H plus ions is very less, weak acid, weak acid, again decrease in H plus ions. Decrease in H plus ion means there is increase in OH minus ions. So increase in OH minus ion means it is moving to the basic. Less number of OH minus ions, less basic. More number of OH minus ions, more basic. So there is a paper called pH paper. That paper, the paper is in our lab. There is a paper like this one strip. This paper you dip in the given solution. You will be getting some color. For example, the color is Suppose the color is like this. So you dipped this paper and you got the color like this. Now you have to match this color with the standard colors given. What are the standard colors given? Let's see. See, these are the colors. We got green color. So you will be matching with this colors given here. And our color is matching with, see, the color we got is matching here. So we say the solution is having a pH. These are the pH values given. Solution is having a pH 6. If pH is 6, then how can we produce? What is the acidic nature or basic nature, or what is the strength of this acid? pH is equal to 6 now. pH means potence hydrogen. pH, P stands for potence, means strength. P in pH stands for potence. Potence. Potence in German, meaning power. So here, in this pH scale, means on this pH scale, we can measure pH generally from 0. 0 to 0 means highly acidic, that is very acidic. Very acidic. Then to 14, that is highly alkaline. Very alkaline. Very alkaline. pH 7. pH 7 means neutral. pH 7 means neutral. So our color is 6. pH 6. So this is less acidic. So acidic character decreases in this way and becomes neutral here. So the solution what is supplied to you is less acidic. Less acidic. Now, if you are getting pH 8, yeah 9, that is less basic. Less basic. If it is 13 or 14, that means highly basic. So here it is highly acidic. Acidic character decreases, less acidic and neutral and less basic. But here also H plus ions are there, and here highly basic, yeah, highly alkaline. Here very less H plus ions are there. H plus, in terms of H plus ions only, we will be finding out the pH. We will be finding out the pH. For any solution, you take any solution in that H plus ions are there, OH minus ions are also there. Suppose OH minus ions are very high, that means H plus ions are very low. Suppose H plus ions are very high, that means OH minus ions are very low. For any solution, there are means H plus ions. For any solution, there are H plus ions and OH minus ions. H plus ions concentration, we show this concentration in square brackets. H plus ion concentration and OH minus ion concentration, if you multiply these concentration, it will be equal to 10 to the power minus 14. 10 to the power minus 14. For any solution, there are H plus ions. For any solution, there are H plus ions, there are OH minus ions. If H plus ions are high, then OH minus ions are less. If OH minus ions are high, then H plus ions concentration is less. In for any solution, H plus ion concentration into OH minus ion concentration is equal to 10 to the power minus 14. pH of a neutral solution is 7. The pH of a neutral solution, suppose pure water you are taking, pure water that is neutral. If you dip that pH paper in that water, you will be getting this color. Values less than 7 on the pH scale, values less than 7 on the pH scale represent an acidic solution. As the pH value increases from 7 to 14, 7.1, 7.2 onwards 14, it represents an increase in OH minus ion concentration in the solution. That is, increase in the strength of alkali, increase in the strength of alkali. Generally, a paper impregnated with the universal indicator is used for measuring pH. So, a paper impregnated means impregnated. Means you dip that paper in that universal indicator solution and write, you will be getting the pH paper. Strength of acids and bases depends upon the number of H plus ions or OH minus ions produced. Strength respectively. Strength of acids and bases depends on the number of H plus ions or OH minus ions produced. If we take hydrochloric acid and acetic acid of same concentration, same number of HCl same number of HCl or same number of acetic acid means CH3COOH in a particular volume, then these produce different amounts of hydrogen ions. These produce different amounts of hydrogen ions. Suppose you put 10 molecules of HCl in water to make 1 liter solution. Another solution, again 10 molecules of acetic acid, that is CH3COOH, in water to make 1 liter solution. Means they are having same concentration. Same concentration means 10 molecules, 10 molecules. They are having same concentration means the number is same. Number is same. What I said? If we take hydrochloric acid and acetic acid of same concentration, then these produce different amounts of H plus ions. Which will give more H plus ions? HCl, hydrochloric acid. Which will give less number of H plus ions? Acetic acid. That is their nature. Acids that give rise to more H plus ions are said to be strong acids. And acids that give less H plus ions are said to be weak acids. Now, this concentration generally we express in terms of molarity. Let's see what is molarity. Molarity. Concentration we always express in terms of molarity. in chemistry. There are other terms also like molality, mass percentage, volume percentage, parts per million, then mole fraction. Such terms we will be studying in class 11th. Now, molarity. What is molarity? That is number of moles of solute. Number of moles of solute upon volume of solution, volume of solution in liters. Number of moles. You learned the term mole last year. Mole. What is mole? Mole, whatever may be the mass, means given mass upon molar mass. Suppose you are given 120 gram of NaOH. 120 gram of NaOH, and this 120 gram of NaOH you dissolved in water, and you added water to that solution, added water, and you made a solution. This is 1 liter solution you made. 120 gram NaOH you added in this 120 gram NaOH in this 1 liter. 1 liter. So, what is the number of moles? How many particles? How many particles? Given mass, that is 120 gram divided by what is the molar mass of NaOH? Molar mass of NaOH. You can add all those things, that is 23 plus 16 plus 1, that is 40. 40 grams per mole. So I am dividing it by molar mass, that is 40 grams per mole. So here this is 3 moles. 3 moles. What is the molarity? What is the molarity? This is 1 liter. Number of moles of solute means 120 grams we dissolved in this. So moles means 3 moles. 3 moles upon 3 moles upon volume of solution in liters, that is 1 liter, which is equal to 3 moles per liter. We call it as 3 molar, capital M. 3 molar. 3 molar means 3 moles of NaOH here dissolved. Here I have taken a base. You can take an acid also. Suppose I added 73 grams of HCl. 73 grams of HCl in 2 liter solution. I added 73 grams of HCl in 2 liters. 2 liters, I'm changing into 2 liters. Molarity is for 1 liter. Two liter solutions. 2 liter solution I have taken. See, 73 gram of HCl in 2 liters. In 2 liters. What is the molarity of this solution? Let's calculate. Moles. How many moles? Given mass by molar mass 73 grams upon molar mass of HCl. Molar mass of HCl is HCl, that is 1 plus 36.35.5, that is 36.5. So I'm dividing this by 36.5 grams per mole. Grams per mole. So, what is the number of moles? Moles means counting numbers, just like 1, 2, 3. Like we say 1 dozen. 1 mole is similar to what we can say 1 dozen. 1 dozen has 12, 1 mole has 6.022 into 10 to the power 23. That we learned in class 9th. Okay, so here, which is equal to 73 upon 36.5, that is 2 moles. 2 moles. Now take this to find out the concentration in molarity. This is in 2 liters. This is in 2 liters. So, molarity is equal to number of moles of solute, that is 2 moles. 2 moles upon volume of solution in liters. See here, 2 liter. See here, 2 liter. See this, 2 liters. So, 2 moles upon 2 liters, that is 1 moles per liter. Moles per liter, that is 1 molar. 1 molar. The concentration can be 1 molar, 0.1 molar, another time 0.1 molar, 0.01 molar, 0.005 molar, like this, or 3 molar. Concentration can be like this. In terms of molarity, molarity means this M. Molarity means this M. So, if you are provided with this concentration term, then you can find out the pH. By using this equation, pH is equal to negative logarithm of H plus ion concentration. Negative logarithm of H plus ion concentration. Now, just now we said here 3 molar HCl. 3 molar HCl means the concentration of HCl is 3 molar, concentration of H plus is 3 molar, concentration of Cl minus is also 3 molar. Why? Because in water, HCl dissociates or ionizes into H plus and Cl minus. You see, HCl in water dissociates or ionizes into H plus and Cl minus. 1 HCl can give 1 H plus. 2 HCl can give 2 H plus. 3 HCl can give 3 H plus. Similarly, 1 HCl can give 1 Cl minus. 2 HCl can give 2 Cl minus. 3 HCl can give 3 Cl minus. Means the number of HCl molecules that you are taking will be equal to the number of H plus ions also. We don't want the Cl minus ions. We want only this H plus ions, because here pH is equal to negative logarithm to the base 10. Negative logarithm of H plus ions. Now, if you are supplied with this concentration, you can calculate the pH. pH value will be ranging from the 0 to 40. pH value will be ranging from 0 to 14. If you are getting pH as 8, then it will be less basic. If you are getting pH, means concentration will be given to you. You have to find out the pH. Concentration will be given to you in terms of molarity. Then you have to calculate pH. Once you get the pH, then you can find whether it is highly acidic, low acidic, or less basic, or highly basic, that you can come to know. Let's do some calculations based on this. Molar concentration is question. Molar concentration of HCl, hydrochloric acid solution. Acid solution is 10 to the power minus 2 molar. Molar concentration of acid solution is 10 to the power minus 2 molar, means 10 to the power minus 2 moles per liter. Calculate the pH. Calculate the pH. So, answer, pH is equal to negative logarithm of hydrogen ion concentration, that is negative logarithm of, that is 10 to the power minus 2, 10 to the power minus 2, log a to the power n is equal to n log a. So minus log 10 to the power minus 2. Log 10 to the power minus 2 means minus of minus 2, that is plus 2. So what is pH? pH is equal to 2. pH is equal to 2 means it is highly acidic. The solution given is highly acidic. Now instead of giving this molarity, they may say that 0.02 mole of hydrochloric acid in 2 liters of the solution. 0.02 mole of hydrochloric acid in 2 liters. So if it is so, the same question, 0.02 moles of hydrochloric acid in 2 liters. In 2 liters. Now here you have to first find out that capital M, that is molarity. So molarity is equal to 0.02 divided by 2 liters, moles per liter. So this will be 0.01 moles per liter, which is equal to 0.01 moles per liter, which is equal to 10 to the power minus 2 molar. They may directly give this molarity, or they may give like this. So you have to find out number of moles upon volume of solution in liters. Then you have to find out the pH. pH is equal to 2. pH is equal to 2 means highly acidic. The question is only to find out the pH, and we have found out the pH. You don't have to write highly acidic. Here, this much is okay. Thank you.